the body which undergoes angular acceleration. You
Ma'am,
know what
when you say rotational motion, so that doesn't include circular motion.
rotational motion that doesn't? No, circular motion is part of a rotational motion, right? A body is rotating about a common center. A body is rotating about a common center, right? But you have to be
Yes.
very careful. You have to be very careful whether there is an axis of rotation. If it is moving about a common center, yes, but rotational motion is the body is rotating not about a common center, it is rotating about an axis of rotation. Fine, boys. Linear velocity, you know what is linear velocity? It is displacement by time. Do you know when a body moves in a circular path? When a body moves in a circular path, then what is linear velocity? Linear velocity is omega. That is nothing but angular displacement by time. Okay, boys, I think so. I need to have a separate slide. Because now you have to be a little bit careful about. I'm just moving on for linear motion and rotational motion. So in linear motion, your velocity is displacement by time. So that is if the body moves, right? The body moves from point A to point B in a time of t seconds, then the displacement final position minus initial position by time. That is what we call it as linear velocity. When the body is moving, rotating, say a body is rotating about an axis of, this is called the axis of rotation. When a body rotates about an axis, right? Now, what is angular velocity? Angular velocity is nothing but, suppose I'm just taking the plane of the motion. So when the body starts from point A is, so your axis of rotation passes through the point O. Theta is the angle displaced in a time of t seconds. So your angular velocity will be angular displacement. Are you clear, boys? Here it is linear displacement. Here it is angular displacement. Actually, generally what we say, this is called the radius vector. OA is the radius vector. So the angle swept by the radius vector in a time of t seconds, we call this as the angular velocity. If the angle swept theta is greater in a given interval of time, then we say the body is rotating faster. Same way you have angular acceleration. Angular acceleration will be equal to angle rate of change of angular velocity. Now what causes angular acceleration? Here, acceleration is equal to dv by dt. What what accelerates a body? A force acting on a body accelerates the body in case of linear motion. In case of a rotational motion, right, the force which causes the body to undergo rotation, or if it increases the angular acceleration or decreases the angular acceleration, then such force we call it as a torque. So now you'll be introduced to a new concept, what we call it as torque. Now, torque can be easily explained, or you can measure your torque, right, with the classic example of opening and closing of the door. What is torque? Torque is a force which causes a rotational motion. This much is enough right now for you to understand. Then we'll go for the mathematical aspect. Torque is a force which produces a rotational motion. Clear, boys? Now you imagine when you are rotating a door, in that sense, when you're closing or opening your door, the door is going to rotate about an axis. Is that so or not, boys? The door is going to rotate about an axis, and that axis of rotation passes to the hinges. You know what is the hinges? Your door, all your doors will have hinges. 11B, you're quiet. You know what do you mean by hinges, boys?
Yes, ma'am.
Yes, ma'am.
Yeah. So your axis of rotation, because your door is going to rotate about an axis which is passing through the hinges. Now, if you want to close the door or if you want to open the door, you are applying a force on the handle or on the knob. Because you apply a force, right? If you want to open the door, you are applying a force towards you. And where do you apply? You apply a force on the handle or on the knob. When you're closing, you're applying a force away from you. Is that clear, boys? So the rotational motion of the door depends on how much force you're applying. If you apply a greater force on the knob, you're going to bang the door. It's that, right? When you apply a force on the knob, you're either going to close the door or you're going to open the door, right? So the rotational motion of your door depends on the force which is going to be applied. And there is one more factor which is going to affect the rotational motion. What is that factor? Boys, think either you're opening a door or you're closing a door. So if you want to open a door or close a door, you have to apply a force. Where do you apply a force? You're going to apply a force on the knob, right? So then you can open the door as well as you can close the door. So what is going to happen? Your door is going to rotate. It's not a complete rotation, boys. It's not a complete rotation. Your door is going to rotate about an axis passing through the hinges. The question is how rapid or how fast your rotational motion, you're opening the door or closing the door, depends upon the force you are using. And it also depends upon one more factor. What is the other factor? 11B.
I said the mass of the door.
Okay. Okay, fine. If the mass of the door is more, then the force you apply is also should be greater. What is the other one?
Perpendicular distance.
Okay, perpendicular distance from where?
I'm from the axis of rotation, I guess.
Correct. Yes, good. Who's that?
Ma'am, this is Jonathan.
Okay, Jonathan. 1 second, boys. Now, what do you mean by perpendicular distance? Look at the door, right, boys? Where generally, where do you locate the knob? Generally, where will be the knob or the handle located on a door? Boys, where do you locate? Where have you seen the knobs being located or the handle being located on a door? Where do you see? Is it at the center or is it near the hinges or it is at the extreme end?
Extreme end from the hinges.
Hinges, okay. Now suppose if I look at this, suppose if I put the handle somewhere at the center of the door. If we put the handle somewhere at the center of the door, is it easy for you to open the door with the same force? Is it easy for you to open the door or close the door?
No, it will become difficult.
It will become difficult. So as your handle or the knob or the point of application of your force, as it goes very close to the hinges, then what happens? The rotational motion, it's very difficult for you to rotate in that sense, very difficult for you to either open the door or close the door. Is that clear, boys? Is that clear? So look at, can you see this diagram where I'm just highlighting with a red marker? Now this is the knob where you're applying the force. Now this will be the hinges, right? The door is rotating about an axis passing through the hinges. Now your knob where you apply your force to close the door or open the door should be at one end of the door, right? If you decrease the distance. If you bring your knob closer to the hinges, then it will be difficult for you to open or close the door. So the rotational motion, please understand, what causes the rotational motion? Torque. Torque causes the rotational motion of a body. Now, the rotational motion of the door depends upon the force which you are going to apply, and it also depends on the perpendicular distance, right? The perpendicular distance between the point of application. Why perpendicular distance? Because when you apply a force on the knob, right, the direction of force is always perpendicular to the plane of the door. Yes or no, boys? When you're applying a force on the door, the direction of the force which you apply will be perpendicular to the plane of the door. So the perpendicular distance between the point where you apply the force and the axis of rotation, now this distance, right? These things are going to measure your torque. We'll see what mathematically it means. Was I'm resharing your file once again because I have to include the audio system.
This is a demonstration of the lever arm and the importance of the lever arm in determining the torque. A torque is a turning force, and the torque is given by this Greek symbol tau. It's the product of the force magnitude and the lever arm, which is a distance measured in meters. So what I'm going to do is I'm going to hand this T-shaped piece of wood to my able assistant Parker, who will grip the wood with his hands. Then I have some hooks here to which I will attach this mass at different locations. So the torque exerted when I attach the mass here will be less than the torque exerted when I attach the mass, say, here. The axis of rotation is here. Parker will be attempting to prevent this T from going down. And as I attach the mass at farther and farther points from the axis of rotation, the torque will increase because the lever arm is increasing. So let's have a try here. See how tough Parker really is. No problem. A lever arm of maybe 20 centimeters. Again, not bad. Not bad at all. And he's starting to strain. That's the best I've ever seen anybody do it. So give a hand to Parker. And but Parker, report to us what was the difference. The mass was the same, but what was the difference?
It gets harder the further it is. It'll start twisting down.
Mm-hmm. Because the turning force, that torque, is increasing as we increase that lever arm. Perfect.
So I think, boys, you could have understood. Do you understand the concept of torque? Boys, do you understand the concept of torque?
Yes, ma'am.
So
Yes, ma'am.
the torque is determined by 3 factors. This you can write, boys. Or else you can write it in your own words, but the what you write is not the definition of torque. The definition of torque is different. You can write torque is a twist or a turn which produces a rotational motion. This is only for your reference, boys. Torque is a twist or a turn torque is a twist or a turn which produces a rotational motion. And torque is determined by 3 factors. So the magnitude of the applied force, the direction of the applied force, and the location of the applied force. Now, why direction of the applied force? Because the direction of the force applied should be perpendicular to the lever arm. That is, when you're applying a force on the knob, right? You're applying a force on the door through the knob. So the direction of the force which you apply, right, on the door will be always perpendicular to the plane of the door. So that is very important, boys. The direction of the applied force. Third one, the location where you apply the force. You have to apply the force farther away from the axis of rotation so that you can enhance the turning effect. Shushal is here. Shushal? I think so. Shushal, can you put a message in the chat box? I have resent your file once again. Just check whether you have received the file, Shushal. If that is the case, then I will send the other files also. Shushal, just check whether you have received your physics paper. If you have received, you just put it in the chat box that you have received the corrected answer script. Now comes defining torque and stating its SI unit. Torque is going to, how do you measure your torque, right? So how do you measure your force in how do you measure force in linear motion? How do you measure your force? But how do you measure your force acting on a body when the body undergoes linear motion? 11B.
Meter.
Mass
How do
into
you,
acceleration.
it is measured by mass and acceleration. Same way, torque is defined, or how do you measure your torque? It is a product of the magnitude of the force and the perpendicular distance between the line of action of force and the axis of rotation. Anyway, now look at the statement. Your torque, we represent it with a Greek letter. This letter, we pronounce it as tau. Right? Tau is equal to F into D. I'll just take it as FD or FR. Now let us take this as D. Now what is D? The perpendicular distance between the line of action of the force and the axis of rotation. Now you have to imagine, boys, the axis of rotation is passing through the point O. Can you look at? See, you have consider a metallic rod, or I'm just considering a metallic rod. Now, one end of the rod is fixed, right? It is fixed at point O. Your axis of rotation, you're rotating the rod about an axis which is passing through the point O and perpendicular to the plane of the monitor. boys, I have a metallic rod, say ON. ON is a metallic rod which is lying on the plane of the monitor. You're looking at the monitor, right? ON is a metallic rod which is lying on the plane of the monitor. Now I'm going to rotate. If you want to rotate the rod, then you should have an axis of rotation. Now, where is your axis of rotation? You're fixing this point O. So your axis of rotation is passing through the point O and is perpendicular to the monitor. Can you imagine, boys? 11B, can you imagine?
Yes, ma'am.
Okay, the axis of rotation is passing through the point O and it will be perpendicular to the monitor which you are looking at. Is that clear, boys? Now, next one is the line of action of the force. Now, how is your force applied? Look at your forces. Your force is acting in the downward direction. You extend, boys. You are extending the direction of your force. Right? You are extending the direction of the force. These dotted lines. Can you see the dotted lines? These dotted lines, which is along the direction of the force applied, we call this as line of action of force. Are you clear? 11B, anyone who is having a doubt, all these concepts are new for you. That's what I'm just repeatedly asking you. Do you understand what is line of action of force? You're just extending the direction in which your force is acting. Your force is acting as per this diagram, your force is acting in the downward direction along the plane of the monitor. So I have used a dotted line. That those dotted lines, those dotted line represent what we call it as the line of action of the force. Now your torque is nothing but the force you're going to apply into multiplied by the perpendicular distance, right? This is ON will be the perpendicular distance, right? ON is the perpendicular distance. Why? Because it is perpendicular to the force. ON is the perpendicular distance between the line of action of the force and the axis of rotation. Can you imagine? Can you imagine? This is your line of action of force. Right? Axis of rotation. Your axis of rotation is perpendicular to the plane. Boys, please understand. Your line of action is lying on the plane of the monitor. Your axis of rotation is perpendicular to the plane of the monitor. Is that clear? It's not a live class. I'm finding it difficult. So your line of action of the force, your force is acting in the downward direction. It is along the plane of your monitor. Your line of action of the force is acting along the plane of the monitor. But yes, what happened?
Should we write this?
Yeah, you have to write. So your axis of rotation, is perpendicular to the plane of the monitor. So the distance ON, which is the perpendicular distance ON, and the perpendicular distance between the line of action of force and the axis of rotation ON, right? That measures your torque. How far you have applied the force. Where are you applying? At which point you are applying the force? That matters. Torque is equal to force into perpendicular distance between the line of action of force. Because I think so you need the diagram also. So can someone now tell me what will be the SI unit of torque? What will be the SI unit of torque?
Was it Newton meter?
Newtons. Okay, Newtons. Boys, you spell this as tau. Shushal, did you receive the file, Shushal? If you have received, please confirm by putting a message in the chat box, Shushal. Have you copied?
Ma'am, he replied no, ma'am.
What happened? You don't know. Okay.
Ma'am, should we draw the figure also?
Which one?
Should we draw the figure?
Yeah, yeah.
Like
You draw
the
the figure.
distance force.
Yes, it's correct. Correct. You should know because
Oh,
this
okay,
is
ma'am.
the basic one. This is the basic one. Later on, we'll see when the force is acting at an angle, right? An oblique force. Now, this is a normal force. We'll see what happens when an oblique force is going to act on the body or on a particle. This is the basic definition. Tau is equal to FD. SI unit, boys. SI unit is newtons into meter. Newtons into meter. Shall I go for the next one, boys? 5 minutes left.
Ma'am, this is a vector quantity, right?
A torque is a vector quantity, boys.
Okay, ma'am.
Shall I move for the next one?
No, ma'am.
No or yes?
No, ma'am.
Torque is a very important concept, boys. Those who are applying for mechanical engineering or somewhat related studies, torque is very, very important. You learn all these mechanics because your physics of 11th grade is full of mechanics. So when you go for your engineering science in mechanics and mechanical engineering, but for all engineering courses, initial classes will be the entire physics will be over there, but still. Fine, boys. Shall I move for the next one, boys? So you can. Now, how will you find the direction of the torque, right? Now, whether you understood or not. Now, suppose, can you see what is written as a page, right? Consider that as a plane, right? You consider that as a plane. Now, let me consider a particle, say P. I'm considering a particle P, which is at a distance of r meters from the origin. Can you see something being written as page? You consider that as a plane or a plane sheet, right? Now you have a particle P, a particle which is moving, or I can say a particle which is rotating. I have a particle at point P, say of mass m, which is at a distance of r from the origin, right? Now, the line which dotted line. Now what you are doing is that you're applying a force on the particle. Can you see the force applied, boys? Can you see the force applied? Now, when you apply a force on the particle at point P, now the force is making the particle, instead of moving along a linear path, it makes the particle to move along the circular path. So now the particle, the direction of motion of the particle is going to change. So, right, your particle now is going to rotate about an axis which is passing through the center, and this is called the axis of rotation. And this axis of rotation is perpendicular to the plane. I'll repeat once again, boys. You have what we call it as a plane, that is nothing but I'll just consider a plane. On this plane, I have a particle at point P, any particle of mass m. Now, the particle is at a distance of r from the axis of rotation. The axis of rotation is passing to the point O and is perpendicular to the plane. So I'm applying a force F on the particle. So when I apply a force on the particle, look at this, the force is making an angle theta with the direction of motion. The particle, right, the particle is at point P. So a force is being applied. This is neither a horizontal force nor a perpendicular force. This is a force which makes an angle theta with the direction of the position of the particle. Now, what does this force do? This force will make the particle to move along a circular path, or it will make the particle to rotate about this axis. So now you have applied a force on a particle. Now this force is going to produce the particle to rotate. It makes a particle to rotate, which means the particle is undergoing a torque. A torque has been applied on the particle. Now what will be the direction of the torque? So what you need to do is that, boys, you have to stretch all the fingers of your right hand along the direction of R vector. All your fingers except your thumb of your right hand, you're stretching along the direction of P, right? Is that clear, boys? And then,
Ma'am, your voice is too low.
okay, my dear, I'm just turning my laptop. So with your right hand, all the fingers of your right hand, you stretch it along the direction of R. Can you have an encircled R vector? Boys, first and foremost, all your fingers of your right hand, you stretch it along the direction of R, and then can you see the arrow? Because you have applied a force. Now what does the force do? The force is going to make this particle to move, to rotate. So now what is the direction of rotation? The direction of rotation is along the direction of the force. So what you have to do is that all these fingers which you have stretched along R, you curve it along the direction of F. You curve, boys, you curl all your fingers in the direction of F. Then in which direction will your thumb point? In which direction will your thumb point?
Ma'am,
Are you-
upwards.
Your thumb is going to point upward, which means the torque is going to act in the upward direction.
Ma'am,
Yes,
so your R is distance, right?
R is the position vector,
Okay.
the distance of the particle from the axis of rotation. Yes, guys. I don't know, 11B, how far you are taking up this. 11B.
So is torque like the cross product of between force and
Yeah, cross product of R and F. R vector and position vector and force vector. Fine, boys, you can.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
You shall know. Thank you, boys.
Thank you.
This is Fadil.
Yes, boys.
Like I didn't